All right, guys, here we go, 10.6b. Today is going to be a video lesson. I apologize in advance, but I might have a scheduling conflict today, so I'm going to teach you 10.6 Part B by video, and hopefully we're still able to Zoom and answer questions and stuff, but here we go. 10.6b, surface areas of pyramids and cones. So to start with, you guys, I want to just define the fact that there's regular pyramids and non-regular pyramids. Regular pyramids have a center that is in the middle, okay, from the middle to the peak is a right angle. The non-regular pyramid, notice where center or where the altitude might be is not the center of the base. Okay, so just a difference in those two things. All the terminology should be very familiar to you. It's all kind of the same here, except for the new one, which is the slant height. Okay, the slant height, this is an important one, is like, you know, if you have a pyramid, it's the face that you see, the height of the face that you see, not the altitude that is in the middle. Okay, so this one will always touch a base. That is called the slant height. We always abbreviate it with a cursive L. Okay, so that'll come in handy here today. Why the formula works? So the formula for one of these pyramids is 1/2 the perimeter times the slant height. Okay, this slide here, I'm not going to go into it too much, but this shows you why that formula would work. But it's essentially just, if you take the perimeter of something, you're calculating all of the bases of the triangles that make up the shape. Okay, so the perimeter just includes all of the sides, right? So this math here kind of shows you why the formula works. Again, you're allowed to use the formula in your test, but it's, because there's a lot of them to remember here, but 1/2 times the perimeter times the slant height, okay? That will give you the lateral area. Then you still have to find the base. So again, here is the formula, nothing new here, works for all types of regular pyramids, okay? Doesn't matter which type because they're all gonna have triangular faces. But then the surface area, this formula will include the lateral area formula, but then we're gonna also include the base formula, which could change, because if you have a square pyramid, right? A square pyramid, the base is, you know, you're gonna use the formula for area of a square, right? But sometimes you might have a triangular pyramid, something that looks like this. If that's the case, then you're going to use, for your base, you're going to use the 1/2 base times height, right? So just so you know, the base formula part of this thing will change depending on what kind of base you have. All right, so let's get into it. For example 5, we have an equilateral triangular pyramid. Okay, so we have a triangle pyramid, it's equilateral, with a base edge of 6 feet, and then it has a slant height, which I guess I can do in a different color here, slant height to the base of 8 feet. Okay, so that's my L, my slant height. Okay, it says to find the, I think in example 5 we're looking for the total surface area. Okay, so in order to find this, what I'm going to do is I'm going to use my formula that we just talked about, which is the lateral area is equal to 1/2 the perimeter times the slant height. Okay, well the perimeter of this thing, if it's an equilateral triangle, would just be 6 plus 6 plus 6. So I'm just going to plug that in. 1/2, 6 plus 6 plus 6 gives me 18. So 18. And they give us the slant height. Okay, so they give us the cursive L there. So my lateral area would be equal to this guy, which I believe comes out to 72. Okay, but I'm not done because I still have to find the area of my triangle there. That's kind of the difficult part. So I have this equilateral triangle with 6 here, 6 here, 6 here. This is my base. So I need to find the area of this thing. In order to do that, I need the height, the altitude, which is not given. But since this is an equilateral triangle, I can cut this into a right triangle and use the Pythagorean theorem. If I do that, okay, so I'm looking at half that triangle, this becomes a 3, this still remains 6, so now I'm using this formula of 3 squared plus h squared for the height is equal to 6 squared. Okay, so then h squared is equal to, I believe that comes out to 27 when you move everything around. If you take the square root of both sides, h is equal to 5.196, I believe. So that's my height. I'm gonna put that into my formula for a triangle, which is base times height divided by 2, or 1/2 base times height. So I have 6 times 5.196, all divided by 2, which equals 15.59. Okay, so there's my two. I have my lateral area, I have my base area. I just add them together now. If I add those two things together, 72 plus 15.59 gives me my 87.6 approximately feet squared. All right, so that's example 5. I encourage you to pause the video and try 5B on your own, but then watch the video and make sure you did it correctly, and then, correct your mistakes if you made any. But here we have a square pyramid. Okay, so we have a square pyramid with a base edge of 12, and it says the height. The height of this thing, and if you tried this on your own, you might have gotten a different answer than I'm going to get, because notice, this is a little tricky, this is not a slant height. This is the height of the pyramid to the center. Okay, so if it just says height, it's talking about to the center. So we actually have to find the slant. In order to find that slant height, what I could do is I could kick out a right triangle to a base. I know that this distance is 6, and I know that this distance is 16, so I could create a picture of the slant height, the L here. This is 6, this is 16, so I would use the Pythagorean theorem. 16 squared plus 6 squared is equal to the slant height squared. When you run your math there, the slant height, it comes out to 17.09. Okay, so now I can just plug that into my formula. So the surface area formula is 1/2 P times L plus B. Okay, so I know the perimeter of this thing, it would be 12 times 4, since this is a square. So that becomes 48. So I have 1/2 48, the slant height, which is 17.09, plus the area of the base. Well, this is 12, so the area of this thing would be 12 times 12, which is 144. And when you run that math in your calculator, hopefully you're getting 554.16 or something like that centimeters squared. Okay, so that is 5B. Again, it just didn't label the slant height. Okay, so just be careful with that. If it says slant height, great. If it doesn't, you have to find it. On to cones. So right versus oblique cones. A right cone is going to have a center that's right in the middle. An oblique, with the altitude that's right in the center, I should say, an oblique cone will have an altitude that is off center. Okay, so the altitude here is not to center. It's to this point right here. So it just curves that cone. The main difference is the altitudes in this thing. That's the main difference. Okay, so the lateral and surface area of a cone. For the lateral and surface area of a cone, we have the lateral area equal to pi r L, which is the slant height. Okay, so just another formula here that has a pi and a radius in it. Then we have, for the total surface area, this one might need a little more explaining. The surface area total, though, should make sense as long as we can make sense of this. We're just adding pi r squared, which is the circle of the base, right? So the total area is the stuff on the sides, which is pi times r times the slant height, and then the surface area would include that, the total surface area includes that, and the base, which is the circle that makes up the base. Okay. There's a little bit of a proof in your textbook as to why we use the slant height here, but if you unroll a cone, you get like a Pac-Man type shape, and the slant height makes up for that missing piece of the circle. Okay, so If you want to look for the proof in the textbook, there is one there. But I'm not going to take the time to do it now. So example 7 here. We're looking at a cone that has a radius of 0.8 and it has a slant height. So here's our cone here. Slant height is 2.2. So that's everything that we need, right? So to find our lateral area here, we're going to do pi times r times L. Okay, when we run that math here, let me just do it really quickly. I think I've already done it. The math here comes out to 5.529 or something like that. And then to find the base, that's going to be pi r squared, which comes out to 2.0096 or something like that. When you add the two together, you end up with approximately 7.5 millimeters squared for your area. Okay. Again, I encourage you to pause the video, try the next one out on your own, and then replay the video and just see if you got it. This is giving us a diameter in 7b. We need a radius, so the radius is equal to 6 since the diameter is 12. So now I don't use this information because I just needed that information to find this information. Okay, then we have the slant height of 7 inches. So here we go. Let's just plug it in again. This is for a cone again in 7b. So the total surface area would be this. Lateral area, which is equal to, again, this is going to be pi times the radius times the slant height. Okay, so that comes out to 42 pi. Okay, so again, I'm just using this guy, pi times r times L, and then I'm going to use pi r squared for the circle. So pi r squared for the circle of the base would be pi times 6 squared, or 36 pi. When I add the two together, okay, I end up with 78 pi, which equals approximately 245 inches squared. All right, guys, that's all I have for you today. Again, I might have an interference with today's class, so this is all you really need, and this is what I was going to do in class. The homework sheets are on Classroom. It says here that they're due Monday, but I think I made them due next time we meet, which, when is that? Let me just check with you guys really quick here. Well, anyway, we'll talk about it on Zoom. Have a good rest of your day, and we'll see you guys soon.